Okay, yesterday we talked about contingency tables, right? We did some of the problems had, like you had to answer some questions about percentages, that kind of thing. To go along with that, we have some more vocabulary. Dealing with contingency tables, it's going to show up in the homework tonight, so don't people be confused. So, there is such thing as called row percentages, and column percentages, and total percentages in a contingency table. So here is an example of row percentages. Now, if you look, you have all these percentages listed along with the actual data values, like the frequency values. And if you add all those percentages up, you get 100%. What that means is they got those percentages by dividing by the total survivors and the total deceased, right? So they were like said, okay, how many survivors were in first class? And they did 203 divided by 711. Right. And then they went and said, okay, how many survivors were in second class? And did 118 out of 711. And so they divided straight across. Does that make sense? So if you added up the percentages, you wouldn't get 100% down the columns, so they didn't divide that way. Right down the row. So you can only answer specific questions about this. So on the homework, you're going to have percentages in a table, but you're not going to have the actual data values. You won't have those. You're just going to have percentages. So and then it's going to list some questions and say, can you answer these? If you can, give it a percent. And if you can't, then don't answer it. So you could answer a question like, what percent of survivors were in the third class? Because it would be dividing by total survivors, and that's what they did to get this table. That would be 25%. You could not answer a question that said, what percent of third class members survived? Because in that question, what percent of third class members survived, you have to divide by the total number of third class members, right? So you could figure out if you had the data values, but if you have this table right here with no data values, just percentages, you can't, that 25% is not what you want. That's the wrong percentage, okay? So that's why people are kind of confused. We'll keep talking about that, but just so, row percentages means you divided it down the row. In the same way, you can have column percentages where you divide down the column. So here's the opposite. I have column percentages because the percentages add up to 100 down the column. So in this table, I could use to answer that question, what percent of third class members survived? Because they divided by the total third class. Does that make sense?
Yeah.
Right. So you should be careful about what questions you can answer and what questions you can't answer when you have that information.
But that one's also divided down the row too, or no?
No. So they went back, and this percentage is not obviously all those percentages added together. That's like the total percent just for that little section.
So you're going to be able to tell whether it's row or column by where the 100%.
Exactly. And then there's also, I don't have an example of that, but there's also, you can have table percentages, and with table percentages, none of these add up to 100, and none of these add up to 100, just this one is 100%. And that means they took everything and divided it out of the total, right? So you could answer questions like, what percent of the passengers did something? Does that make sense? Okay.
So they're going to ask some questions on tests and quizzes that you can't answer.
I'm not going to do that to you. Like on the quizzes and tests, I'm not going to do that to you. But there's some homework questions tonight where you might have to look at it and say, okay, I can't answer this question. And it tells you it specifically. It's like, which of these questions could you answer? Just a matter of making sure you knew what row percentage and column percentage meant. Okay? All right. So then the rest of chapter 3 is segmented bar charts. And it kind of puts together ideas we've been using, like actual bar charts, and then conditional distributions where you're looking at percentages of a specific category. For a segmented bar chart, you have a bar for each category that you're looking at, and then segments for the conditional piece within each. So because of that, if you add up all of the segments, you should always get 100%. So no matter how many bars you have, they're always going to be the same height at 100%. So you can, like at the very beginning, you can always build a template. You just got to fill it in with the segments. And so then the segments show the relationship between the variables.
So they're always going to be at 100% no matter what.
Yes, always be at 100%, no matter what, because those percentages have to add up to 100%. Now, in the book, when you're doing them, sometimes it's like 100.1% because of how you round. That's not an issue. If you actually didn't round, you would have exact numbers. So what you can do here is you can look to see if there's a relationship between the variables. So here we've got the Titanic again, and we have survival as your 2 bars, and then you have the classes as the segments. So we say, there's 2 ways you can say this. You can talk about independence. The variables are independent of each other, okay, if independent means they aren't related, all right? So independence means no association or no relationship. And so there's no association or they're independent if the bars look pretty much identical. All right? So they don't have to be exact matches. But all the segments should be line up about the same. So because of that, you always want to put the categories in the same order in your bars so you can compare the categories across. Doesn't matter what order you put them in as long as they match. Okay? So in this case, the bars are not identical, right? They're different. So we would say they are not independent variables. I don't know what that E was about. Or there is an association or is a relationship, which makes sense. On Titanic, everyone in the first class saw first, right? That makes sense that there would be a relationship. Like one was dependent upon the other. So tonight when you do the assignment, you'll have to make a segmented bar chart and then talk about independence. But we're going to do one together so you see how one gets made. Okay? Does that make sense what they're showing? Okay. So here is an example about politics. And it says, look again at the table of political views for the intro stat students in exercise 22. So here's that table. And so it was a class of 192 people, and they had to put on a survey their gender and then their political leaning, liberal, moderate, conservative. Okay? And so in part A, it just says, find the conditional distributions, which is just the percentages, of political views for the females. I could break that down to 3 different questions. I could say, find the percent of liberals for the females. Find the percent of moderates for the females and conservatives for the females. So on part A, I'm finding all 3 of those percentages because they're also going to end up being our segments for our chart later. So we're doing political view for the females, so we're going to take it out of the total 77 females, right? Right. So 35 divided by 77, 36 divided by 77, and 6 divided by 77. So let me find those percentages real fast because we'll need them. So 45.5. $46.8 and 7.8. Right? Okay. So then that's just for females. Then in part B, it says do the same exact thing for males. So, which again, which makes sense. We're going to have to do this for both the bars. So, for males, we have 50 out of 115, 44 out of 115, and 21 out of 115. So I need to, again, find the percentages. You have to find the percentages so you can build up your bars. So 43.5. 38.3. 18.3. All right. So then C says to make a graphical display that compares the 2. So we're going to make the segmented bar chart to compare the 2. So I've got 2 bars. My categories down here are going to be gender. So I have a female bar and a male bar.
Does the scale always have to be 10 or should it be like 20?
You can count by whatever you want on the side as long as you're counting up to 100. So I'm going to do 10, but it doesn't really matter. Right, as long as you have up to 100. So to make the segment, so you just start with one category and then you keep adding up. So 45.5, somewhere in here. We can't color code ours like the book does unless we want to have color pencil all the time. So just mark what category it is in the bar. 45.5 plus 46.8 is 92.3. So our next hash mark is going to be there. And so that means this little part is conservative, right? We do the same thing for male. So 43.5 plus 38.3, 81.8. So there's my segmented bar chart. And so then in part B, it says, do the variables politics and sex appear to be independent? Well, if I'm looking just at the liberals, those are about the same. But if you look at the rest of it, with males, moderates and conservatives is a little bit different than females. So because of that, right, we would want to say that this is, there's either, looks like there's an association, is one way to say it, between variables, right, or not independent. And we'll talk a lot more about independent later in the book. So I like kind of looking at it as an association. Is there a relationship or not? So that is pretty much all we're talking about. That's the end of chapter 3. Does that make sense?